Hey y'all. So today's lesson is square root and cube root functions. So just a little bit of background. Here the square root function is the inverse of x squared, and the cube root function is the inverse of a cube function. So this is just a quick way to show you. The square function, here's a t-chart, and here's a t-chart for the cube for the cube functions, and then I graphed them. The red line is x squared, it's a parabola, and the blue line is x cubed. Well, the square root function and the cube root functions are inverses. In our study of inverses, we know that means they are two things. The coordinates are reversed, so it reflects over the line y equals x. The two things about inverses is the coordinates are reversed. That means all of the domain is now range and all the ranges are domains. And it's reflected over the line y equals x. So if you could see the line, let me get a different color. Okay, green. You saw the line y equals x. Okay, sort of. Then you could maybe see that my functions are being reflected over this line, meaning let's take the parabola, the x squared. If we took it over this line and we folded our paper and we reflected it, it would look something like this. And that would be the square root function. If we wanted to take the blue cube function, cube, and we wanted to flip it over the line, it would look like this. Okay, now that's a lot of writing. I just wanted to show you. I'm going to take each one and individually go through some of the key characteristics and show you a picture of the square root function and the cube root function. But I just wanted to show you, see how they are reversed. So over here it's negative 2 and 4 and 2 and 4. So in the square root function, it's 4 is plus or minus 2. And then the cube root function and the cube function are reversed as well. So first let's take a look at the square root function. Here is a picture. Now I want you to notice that we only see the top half, because if we were to draw the bottom half, it would not pass the vertical line test. Therefore, we have to restrict the domain because we want it to still be a function, a square root function. So we're only going to look at the top half, which means the vertex is at 0, 0, the origin. The domain is going to be x is greater than or equal to 0, so we're only really looking at the top half. That's why we're restricting the domain.
Ms. Klein, please go back to Ms. Freeman's room. Melanie Klein, please go back to room 720. Thank you.
The range is also going to be greater than or equal to 0, because if we're only looking at the top half, it never is going to go below y0. The end behavior, so let's look at our function. Let's look at the right. As we go to the right, we see there's an arrow, which means it's going to be increasing. It's always going to go that way, so it's increasing. As we go to the left, it stops, because we've restricted the domain. And then this function is not symmetric. X squared, the parabola, is symmetric, but the inverse is not symmetric. So that is a little bit about the square root function. So now let's look at the cubed root function. Here's a picture of the cubed root function. This is the cube function reflected over the line y equals x, and the coordinates are reversed. So it is kind of a S-looking thing. The vertex is still at 0, 0, and the domain and range are all real numbers. So this one we don't have to restrict because it's still a function. It passes the vertical line test. The end behavior. As we look at the right, it is increasing, but much like the square root function. As we looked at the left, it is decreasing. It is going farther and farther in the negatives. So the right and left are both going continuously, but one is increasing positive and one is decreasing negative. although it says increasing. All right, I need to go check. Hang on. It says increasing, but right, I wrote it wrong. Sorry, it's decreasing. I said it right. Decreasing. So, sorry if you copied that. It's decreasing, which should make sense because it's going in the negatives. And for symmetry, although this is not symmetrical, meaning you could fold it over a line, it is rotationally symmetric, meaning if we rotated it around, like if we took this line and we rotated it around, it still could be symmetrical. But that's called rotational symmetry, and that's not line symmetry. Line symmetry means you could fold it over a line and it's symmetrical. Rotational symmetry means you can rotate it. So this one does have rotational symmetry. All right? So this is a lot. I'm going to let you copy it down. Transforming a cube root or square root. We've done a lot of transforming. It seems like every function we have, we transform it. And I've given you just a few hints and reminders. Translating, reflecting, and dilating. Nothing new. It's everything we've done so far. And in the reflecting, this part can sometimes get a little confusing. If the negative is inside the radical, meaning it's to the x, it's going to reflect over the y-axis, which means it's a horizontal flip. So let me show you. If you have, let's say, a dot right here, and we are going to put the x on the, we're going to put the negative on the inside. That means it's going to reflect across the y-axis, so it's going to reflect over here. And that is a horizontal flip, a horizontal reflection, because it's going from left to right. If the negative is on the outside of the radical, that means it's going to reflect over the x-axis, so it's going to be a vertical flip because it's going to end up flipping down or up, so it's going to be a vertical flip. And then it's going to be a stretch or a shrink or a compress, depending on what that dilation, that scale factor is. So let me just show you a few. The first one, we have the square root of x minus 3. Because it's on the inside and it's minus, that means we're going to go 3 to the right. All right? This is the cube root of x plus 4. This is on the outside and it's plus 4. So since it's on the outside, that means we're going to go up 4. That's what I wrote. Number 3, we have a negative cube root of x. Since the negative is on the outside, this is a reflection. That means it's going to reflect over the x-axis. It's going to be a vertical flip. So where it was positive up here, now it's going to go down. And then number 4, we have a negative on the inside and a minus 2. So we have 2 transformations. The negative on the inside means it's going to reflect over the x-axis. The minus 2 is on the outside, so that means we're going to go down 2. All right, and we've done all these before. All right, so the last one. Let's do these together. Here we go. F of x equals 2 times the cube root of x plus 3. We have 2 transformations going on. The 2 on the outside, that means it's a dilation. It's going to be a stretch of a scale factor of 2, because that's greater than 1, so it's going to be a stretch. And then this is on the inside. Since it's on the inside, remember we have to go opposite, so it's going to be left 3. Okay. Number 6, we have a 1/2, we have a minus 1, we have a plus 5. So we have 3 transformations going on. The minus 1/2 is going to be a shrink or a compress with a scale factor of 1/2. The minus 1, so this is on the inside, that means we're going to go to the right 1 unit. And then this plus 5 dictates that we're going to go up 5 units. So we would take the parent function, the square root function, and we would shrink it, we would go right to the 1, and then we would go up 5. I don't know if you can see the screen, but the green says, what about f of x, the square root of 4x minus 12? All right, when you see 4x minus 12, we can't determine the transformation, so we need to change it to a better form. We need to change it to a better form. So let me show you what I mean when I say change it to a better form. Here's the example, 4x minus 12. I can't tell what is going on because, well, first of all, we need x by itself. So I have rewritten it, and I factored out a 4. 4x minus 12, I factored out a 4, and I'm left with x minus 3. So I'm on the right track. Because this is multiplying, you agree this is 4 times x minus 3. These are factors. 4 times x minus 3. I separated them into two radicals because I can see the square root of 4 is going to come out to be an integer answer, 2. So I have the square root of 4 times the square root of x minus 3. And once I do that, I don't need my parentheses anymore because I've separated these into two products. I took the square root of 4 is 2. I bring this down. Now I can see my transformation. 2 times the square root of x minus 3. The 2 on the outside means there's going to be a stretch with a scale factor of 2. And the x minus 3 means it's going to shift to the right 3 units. All right, that was complicated. Let me do this one with you. The cube root of 8x plus 32 minus 5. So I know that this minus 5 means it's going to go 5 down. I factored out an 8, so I have x plus 4. Then I broke it up into two factors, the cube root of 8 and the cube root of x plus 4. The cube root of 8 is, funny enough, 2. And now I can determine what my transformations are. The 2 on the outside means it's going to be a stretch with a scale factor of 2. The plus 4 means it's going to go left 4 units. And the minus 5 means it's going to go down 5 units. Okay? Now you try this one on your own. F of x equals negative square root 9x minus 18. So I want you to change this into a form that you can you can describe the transformation and then pick out the transformations. Press pause and then press play when you're ready to see the answer. So I have changed the form. I haven't actually changed the value of this function. I just changed the form. So it's the negative 3 times the square root of x minus 2. And by doing that, that means I have a reflection. I'm running out of room. All right, go here. A reflection over, because it's on the outside, reflection over the x-axis. I have a stretch with a scale factor of 3, and then I'm going to go right 2 units. Okay? And I know this was a lot, but we will practice more with cube roots and square roots in class.